Here's the second half of Unit 6, and we're going to learn about empirical and molecular formulas. Here's the warm-up to 6.4. You want to calculate the molar mass and the percent composition of each element in the following. Pause the video and then come back to check your answers. So the first one, A, is LiClO4, which is lithium perchlorate, or perchlorate. And so here we go. Let's calculate the molar mass. Li is 6.94. There's only one of them. Cl, not Ci, because it's chlorine. There's one of those. And I'm finding these numbers off of the periodic table because it's the masses. Oxygen is 16. There happens to be 4 of those, which is 64. Remember, you add all of these together to get the molar mass. So that is the molar mass. Now, you need to find the percent composition of each. So I'm going to do lithium first, which is the part divided by the whole times 100. So lithium's going to be 6.52%. And I just rounded to 2 decimal places. Chlorine is going to be 35.45 divided by 106.39 times 100%. So 33.32% chlorine. And then oxygen is going to be 64 divided by 106.39 times 100. We rounded 2 decimal places, so it'll be 60.16% oxygen. So when you break it down, these are the percent compositions for lithium perchlorate. Let's do the next one, which is potassium chromate. I have potassium, and that's 39.10. There's 2 of them. So I'd get 78.02. Cr is chromium, and that's 52 on the periodic table, times 1, so it's just 52. Oxygen we know is 16. There's 4 of them, 64. Again, we add them all together, so we're going to get 194.2 grams per mole. That right there is your molar mass. Same thing, I'm going to do potassium first to get the percentage. 78.02 divided by 194.2 times 100. If you round to 2 decimal places, you'll get 40.27% potassium. For chromium, it's going to be 52 divided by 194.2 times 100. And you'll get 26.78% chromium. And then oxygen, it's going to be 64 divided by the molar mass times 100. And you're going to get about 32.96% oxygen. So that's for potassium chromate. The last one, which is magnesium nitrate. Magnesium is 24.31. There's only one of those. And is nitrogen, because there's 1 in the parentheses and 2 on the outside, it's going to be 14.01 times 2, which is 28.02. Oxygen, there's 3 on the inside, but because of that 2, you're going to do 16.00 times 6, because 3 times 2 is 6, which is 96. And we add all these together to get a molar mass, 148.33 grams per mole. And now we got to find those percent compositions of each element. So I'm going to start with magnesium, 24.31 divided by 148.33 times 100. rounded to 2 decimal places, I'll get 16.39% for magnesium. Now I'm going to calculate nitrogen, so I'm going to take that 28.02 divided by 148.33 times 100. I'll get about 18.89% nitrogen. And the last one's oxygen, which I'll move over to the side. It's going to be 96 divided by 148.33 times 100, which is about 64.72% oxygen. Let me box these answers together. And that's the warm-up for 6.4. So 6.4 is formulas of compounds. What is the meaning of empirical formulas of compounds? How are these formulas different and how are they similar? Well, they're similar because they both have carbon, hydrogen, and oxygen. They're different because the first one on the left side, it only has 1 carbon, 2 hydrogens, and 1 oxygen. And on the other side, the right side, it has 6 carbon, 12 oxygen, and 12 hydrogens and 6 oxygen. So this, the one on the left side, that is what you're going to call the empirical formula. The empirical formula. The other side, this is what you call the molecular formula. The molecular formula is the actual formula. The empirical formula is going to be the smallest whole ratio of the molecular formula. So to go from the molecular formula to the empirical formula in this case, we divided by 6 because all these numbers could be divided by 6 and still get a whole number. Remember, if there's no number, it's an invisible one. So take some time to find the empirical formulas given these molecular formulas. Pause the video and then check back in for the answer. So one is C6H6. If we divide both of them by 6, we would get CH as the empirical formula. C12H4Cl4O2, we can divide all of those by 2, and we get C6H2Cl2O. This bottom one, C6H16N2, you can divide by 2, and then I would get C3H8 and N. If you're not very good at finding this, the number to divide by, if they're all even numbers, you can just divide by 2 until you can't. Sometimes it's 3, but you want to keep dividing until you get the smallest ratios, the smallest numbers in your subscripts, and they must be whole numbers. So that's 6.4. Moving over to 6.5, this is calculations of the empirical formula. So how are the empirical formulas calculated? There's 3 wonderful steps. Step 1, you're going to convert to moles of each atom. Step 2, you want to divide each number of moles by the smallest number of moles. And step 3, multiply by the smallest number. That will convert all numbers to whole numbers, if not in whole numbers already. Let's put those steps to this wonderful problem. You're going to calculate the empirical formula for the following. 0.6884 grams of Pb combines with 0.2356 grams of Cl to form a chloride of lead. So step 1 is to convert to moles of each atom. So I'm going to convert my 0.6884 grams of Pb, which is lead, and I need to convert that to moles. I'm going to find that number off of the periodic table, which is 207.2 grams of Pb to 1 mole of Pb. I know grams of Pb will be at the bottom because I started with grams of Pb and I'm converting to moles. So when I put that in the calculator, I like to personally round out to 4 decimal places, or 4 sig figs. So 0.003322 moles of Pb. Let's do the same, but for chlorine, 0.2356 grams of chlorine. Draw your wonderful line for converting. 35.45 grams of chlorine for every 1 mole of chlorine. Because I started with grams of chlorine, it's at the top and it's at the bottom, so they cancel, allowing me to convert to moles. This will be 0.006646 moles of chlorine. Now, the second step is to divide each number by the smallest number of moles. My smallest number of moles happens to be 0.003322, so the amount of lead that I had. And I have to do the same for the next one. When I divide these, I'll get 1. And this one won't be exactly 2, but it'll be 2.0000. And that is close enough to 2. When you have 0.00, a lot of zeros, that's more or less that whole number. If it's like 0.999, that's also more or less the whole number. So now, what do these numbers actually tell me? Well, they give me the empirical formula. This is saying I have 1 lead and I have 2 chlorine. So my empirical formula is PbCl2. Congratulations, you just calculated your first empirical formula. Now, if you're just given percent compositions, you're going to assume it's out of a 100-gram sample because percent is out of every 100. So if I'm given 65.02% platinum, I can actually say that's 65.02 grams of platinum. And again, step 1 is going to be to convert to moles. So I find platinum's mass on the periodic table, which happens to be 195.08 grams of platinum to 1 mole of platinum. My grams of platinum will cancel. When I put this into the calculator, I'm going to get 0.3338. I'm just going to round to 4 decimal places. Moles of platinum. I do that with nitrogen. I have 9.34 grams of nitrogen. 1 mole of nitrogen will be at the top. 14.01 grams of nitrogen at the bottom, because that's the mass of the periodic table. Grams of nitrogen will cancel, leaving you with moles, and you'll get 0.6667 moles of nitrogen. 2.02 grams of hydrogen. Draw your line. The mass of hydrogen is 1.01. 1 mole of hydrogen is at the top, because remember, we're going from grams to moles. Your grams of hydrogen will cancel, and this will equal to 2 moles of hydrogen. Chlorine, 23.63 grams of chlorine. The mass of chlorine will be at the bottom, which is 35.45. 1 mole of chlorine will be at the top. Your grams of chlorine will cancel, and this will be 0.6666 moles of chlorine. The second step is to divide by the smallest amount of moles, and that happens to be the number for platinum. So divide by 0.3338, divide by 0.3338, divide by 0.3338, and same for the last one. This will be 1, this will be 2, this will go to 5.99, which we will just round to 6, because that's more or less 6. And this will also be 2. Well, they'll be like 2.00 something, but that's practically 2. Now, we're going to take these wonderful numbers, right? 1 platinum, 2 nitrogen, 6 hydrogen, 2 chlorine, and that's our empirical formula. We'll have PT(N2H6Cl2). Congratulations, we just calculated the empirical formula from the percentages. Now here's the last section of the mole, 6.6. How is the molecular formula calculated given its empirical formula and the molar mass? The 3 steps we're going to follow is step 1. Calculate the mass of the empirical formula. 2. Divide the mass of the molecular formula by the mass of the empirical formula. And step 3, you're going to multiply the subscripts by answer from step 2. Here's a problem. The molar mass of the molecular formula is 98.96 grams per mole. And the percent composition is the following. 71.65% chlorine, 24.27% carbon, and 4.0% hydrogen. If I'm given percentages, I need to calculate the empirical formula first, because without the empirical formula, we won't be able to get the molar mass. Since they're in percentages, remember, we're just going to assume it's out of a 100-gram sample, and the first step is to convert to moles. So 71.65 grams of chlorine. The molar mass is 35.45 grams of chlorine for 1 mole of chlorine. Your grams of chlorine will cancel, leaving you at 2.0212 moles of chlorine. And again, I just go out to at least 4 decimal spaces. Unless it starts with 0.00, then I just ignore those and do the first 4 numbers after all the zeros. 24.27 grams of carbon. Carbon's molar mass is 12.01. 1 mole of carbon at the top. Your grams of carbon will cancel. You'll get 2.0208 moles of carbon. Hydrogen is 4.07 grams of hydrogen, 1.01 grams of hydrogen to 1 mole of hydrogen. Your grams of hydrogen will cancel, leaving you with 4.030 moles of hydrogen. The next step is to divide by the smallest number, which happens to be the amount of moles in carbon. So 2.0208, 2.0208, 2.0208. This is practically 1, 1, and 2. So we have our empirical formula, which is your EF, which is ClCH2. So step 1 on how to calculate the molecular formula is to find the molar mass. And so the molar mass of this is going to be 35.45 times 1, because we only have 1 chlorine, plus your 12.01 times 1, because we only have 1 carbon, plus your 1.01 times 2 for your hydrogen. And this gets us 49.48 grams per mole. So that's your molar mass for your empirical formula. In the story problem, it says the molecular formula is 98.96 grams per mole. So the next step you're going to have to do is you're going to have to do the molecular formula's mass divided by the empirical formula's mass. So that's going to be 98.96 divided by 49.48, and we get 2. So we can finally do the last step. I don't know why I wrote over 2 so many times, but the final step is to multiply the subscripts of the empirical formula by this number. So the subscripts would be these numbers here. So overall, your molecular formula is going to be Cl2C2H4. Congratulations, you just calculated the molecular formula given its mass, and you had to find the empirical formula. If you have any questions, send me an email, but good luck on your homework, and thanks for watching.